somehow. Hello everyone, welcome to our newest episode of CATIA Systems Talks. My name is Honorata Frinks, and today you will get the chance to learn how to cope with multivariant system architecture and design. Our speaker today is Darius PETRAUSKAS, expert for CATIA MBSE solutions. Welcome, Darius.
Hi, everyone.
Hi there. After the presentation, you will have the chance to ask questions during our Q&A session. And now I hand over to Darius.
Thank you, Honorata. I will. So, as Honorata has mentioned, I'm a senior model-based systems engineer consultant, working mostly in the area of mobility, and irrespective actually in which area I work, the topic of variability eventually comes up. And since most of you know that the primary artifact coming out of model-based systems architecture is model-based systems engineering is architecture, and we have variability usually associated with it. And it's sad for me to say that the concept of variability is actually one of the hardest to implement, not because it's the hardest to grasp, but it's due to the high possible combinations and variations. It is very hard to manage. So before we start, and actually now we are starting, and first we need to understand what is variability and what is a product line. So here we have a very basic example. So we have a generic version of the phone, and we also have a pro edition of the phone. So not getting into details what's inside, but let's focus only on what we can see. So what we can see is we can see that both of these phones have a camera module, and camera module is a component on the architectural level, right? So on the architectural level, we are mostly concerned about interfaces being compatible, and functionally everything is being compatible with the other functions of the phone. But architecturally, we have a camera module here with two lenses, with two cameras, and here we have an architectural model with three cameras. So on the architecture level, the camera module has to support the telephoto lens. So on the generic edition, it's not present. On the Pro edition, it is present. But if we focus on what we actually see, is that we are now transitioning to the domain of design. So architecturally, we do not typically take into consideration of the dimensions of the camera module, but on design side, as it's evident here, and ultimately on the implementation side, we do. So I think this is one of the most important takeaways of this presentation today, is knowing where the variability actually is. And I've seen it numerous times, whether you're a practitioner or a consultant like me, whether you're on the end user, it is very important to directly identify where the variability is manifesting on. So whether it's on the architectural side or whether or not on the design side. So once again, both of these phones have a camera module, except the Pro edition on the architecture side has the camera module optionally with a telephoto component. And if we're talking about things like resolution and sensors or lenses, these are the elements that we're concerned about on the design side. So a little bit further on. So I hope that the introduction was clear. And we have some terms that are cross-cutting, meaning it's irrespective whether it's the design side or the architecture side. And let's go over through them really quick. So if we're talking about any kind of variability, we have a feature model, meaning that's what's totally in essence available for choosing. We have the recorded configurations. In essence, this means that the configurations or the end products or the choices made from what is available for choosing to shape our end result. And whether or not we're talking about a system architecture model or a design model, we have to first have a model, a 150% model, defining everything that is possible and everything that can vary. And by having those three components, we usually can use the automated features of the tool to derive a 100% system model or a design model, doesn't really matter here, based on the configuration or the end outcome that we desire. So this is a very brief theoretical part. And now let's switch to the actual implementation. And first we focus on the architectural definition. So for the architectural definition, I'm using either of the Cameo or now the current portfolio CATIA tool portfolio, meaning whether you use Magic Cyber Systems Engineer or Magic Cyber System of Systems Architect, it really doesn't matter. As long as you have the core modeling domain in place, the variability concept applies on any of your models. So as mentioned before in the previous slide, let's start with a brief overview of the 150% architectural model. So this is let's say, a dummy model of the car. And imagine a car, the technical priority is not the real key of this presentation, but what we can focus on, that the car is composed on various subsystems and components in terms of like that. But for our presentation purposes, just to illustrate the features and how it feels in practice, we say that, okay, so the car is composed of a couple of components, and let's focus on a couple of them. So first, we have the definition of the decomposition of the car into various components, and in the 150% model definition, we have to take into account everything that is possible, irrespective of the feature set that is applicable. So this is the first part. And since we're talking about features, let's now switch to the feature model. So the feature model is in the context of system architecture and how it is implemented in CATIA Magic, is a basic UML-based hierarchical feature model. In simplest terms, it's what is available for choosing, meaning that we have a complete feature model, it's a hierarchical feature model, and we can, for example, have features that are present or not, like here navigation, it's a Boolean, basically it's a yes or no, or we have an engine with a set of choices. It's essentially that simple. So we have a set of features, what is available for choosing, it's either yes or no, or a number of choices that you pick directly for your specific configuration. And the next part, if you remember from the slides, is the configuration. So sets of choices made. So what is your desired end outcome? What is your end product? So let's pick one particular configuration, which is, let's say, a fancy car configuration. And for the fancy car configuration, we pick that we want to have a gasoline 2.2-liter engine, as an example, and we want to have a high-end audio system. And this is something that you would do when you would order a new car from any manufacturer, if you can afford a new car in the first place, by the way. So this is very similar. So I want this feature, I do not want this feature. If I can pick my choices of this feature, I pick my choices of this feature. And then in the end, I want to define, and I have defined my end result that I want to have. So features, what is available for choosing, everything that is possible, and then what choices were actually made. And based on what choices are actually made, we name this configuration, or we have a specific end product or an end-oriented outcome. So we have those two sets of, let's say, artifacts that are independent, basically, whether we're talking about architecture or design. Right now, we're focusing on the architectural side. So if we come back to our 100, let's say 50% definition of a car, we can note that there are some V icons in those diagrams here. And those V's are what are called variation points. And we have several kinds of them. But first, they are defining what is variable in any model. So what can potentially change? And we have three of those. So first is existence based, whether the feature impacts the model that something is available or not, whether it's present or not, something that is changed or modified in a particular way. In essence, this is more or less it. And I do not want to go too technical, but if we have a quick look, we have several kinds of variation points. We have existence, whether it's present or not. We have a property change or an element property change. A property change is meaning that an integer value for the default maximum mass for a car can be modified, or an element property, meaning that another UML-based object can be set as a property to a part that then is variable. So for example, for an engine, we can have any of these blocks set ultimately as a type for that engine. So this is the principle. But if we look at one of the variation points, for example, let's take this one, and this is an element property variation point, we have something defined inside it. So if the feature in the configuration is a gasoline engine or diesel engine, correspondingly, the engine type for in this architectural model is either set to atmospheric engine or turbo diesel, for example. And the other important component on the technical level is that we're testing the engine feature for having an impact to the definition of this variation point. So I think this is as technical as we have to go on this level, and let's see what the implications are when we want to actually preview and realize a 100% system model from based on entirely what is possible on the architectural definition and what we have defined for specific configurations. So how it would look like. So now we have a car that is encompassing everything that is possible to have in that car. And since we have the feature model and the configuration model defined, and it is used in this project, in this 150% project that contains the architecture of the car, I can choose potentially a fancy car configuration and apply it. So what has now happened? So immediately the tool indicates for me what the impact of this fancy car configuration will have on my architecture. So green means something will be kept, yellow means something will be modified, and red means something will be removed. Essentially, it is that simple from the basic perspective. So here we only have the preview, and the preview is different from depending on which configuration we choose. And by the way, the preview cross-cuts every possibility, every, let's say, view of the system model that we have. So potentially our requirements could change or can be modified. Potentially our functional breakdown can change or can be modified or stay the same based on what configuration or what the end result is defined and is chosen. So since we have a fancy car configuration, and by the way, if you know how to expense fancy cars on business travels when you return home, please drop a note to me. But since we are picking the, let's say, the fancy car configuration, most of the architecture will be most of the features or most of the components that we have defined in the architecture will be available to us. So this is the generic principle, but right now we're talking about just the preview. So how would we transform this 150% model into actual variant system model? So the model based on the configuration that you choose, in our case, a fancy car. So for that, we have a mechanism called model transformation, and the specific kind of model transformation is a variant realization. And for the variant realization, I will choose the scope as the entire multivariant car model, and then I will choose a specific configuration. So a specific configuration, since we talked about a fancy car, I choose that I want to have a fancy car realized on top of my 150% model, and simply click finish. And now, as some of you have noticed, something has changed. So now a car directly has not an abstract engine, but an atmospheric gasoline engine. Some parts were kept, some parts were removed in turn. And immediately, if we note in the top left of the corner, we see that we now are operating with a variant model. So it's a specific realization of a fancy car on top of our architectural domain. So if I undo it a little bit, so you see that in the generic 150% model, we have everything that can potentially vary. And if I switch back to our variant for the fancy car, the maximum mass is this. We have 2 doors, we have a red color, and we have an atmospheric engine. So this is the realization of the actual variant, meaning the fancy car. So stepping back again, we had this. We had a set of features from what we can choose. We defined that we want a fancy car. We just named it that based on the feature set that we have. And then we have realized a 150% system model from based on the fancy car configuration. So basically, this from the technical standpoint is all there is to it. But now actually let's switch to a little bit of a broader scope. So I have mentioned before that we potentially may have a feature model, and we can have recorded configuration. So this is a generic variability information, irrespective of which domain we could apply it to. So now it is very important to mention that everything that was shown here is in the scope of the architecture. So when we're talking about any architectural tool like a CATIA Magic Cyber Systems Engineer, we're operating purely on an architectural level. So now let's broaden up the scope a little bit and switch to the 3D Experience platform. And specifically, let's go to a very specific role and a very specific app that is accessible to us based on our role. So if we search for model definition app, so this is an Anovia widget, and it allows us to access the definition of variability that can be performed in Anovia. So in Anovia, here we basically have the same thing. We have the feature model, so what is available for choosing, same thing, the engine types, and also in Anovia, we can define product configurations, or the configurations that we talked about here all along. So we also have here a simple configuration or a luxury-based configuration. And by the way, references go to the R&D team who prepared all of these samples and implemented these features in the first place. So thank you all for doing that. So we have what's available for choosing, and if we choose a specific configuration, we have sets of choices made. So we have a luxury configuration of a car here. So continuing further on, we can bring in this configuration to the CATIA Magic environment, to our architectural environment. And how to do that? What are the prerequisites? So if we go very briefly here to our extensions of CATIA Magic, we have a set of extensions possible to install on the CATIA Magic toolset. So to be able to manage variability on the architectural level, we need the variability core. We need the model product line engineering plugin, and if we want to bring in the Enovia model definition, we need also this 3D experience on model definition integration installed. Once you do that, what is available for you is that you can bring in the Enovia model definition data into the environment of CATIA Magic. And how to do that? Briefly, I can do a quick example. So we can say that this variability information is should come from Enovia, and then it is as simple as connecting to the platform and choosing a specific variability set that can be imported. So in this case, I am once again choosing a car, in this case revision B, and this is actually all there is that I need to do. And now if I look at my variant preview options, I have my features and configurations, more specifically configuration set for the car feature model, and this one was brought in from Enovia. So a suggestion from me is, if you're using the platform, to define the feature set and the configurations in the Enovia app, because if you do that, then the variability information is immediately accessible for all of the RFLP objects, meaning that requirements, functional, logical, and physical objects that are available in the 3D Experience platform, the scope of the 3D Experience platform, and various apps that are accessing it. So this, in principle, is the overview of how variability is defined and managed on a very high level. But if we want to go on a deeper level, the important thing is to, of course, dig deeper. And this link provided to you is to the post where you can find more additional resources to really dive deeper in the scope of this topic. So this is now more or less it from me. And now we may switch to the Q&A session to answer any and all possible questions that you had.
Thanks, Darius. That was very, very interesting. You can type your questions into the comment pane, and we will read them here, and Darius will answer them. And let's wait a little bit and see if we have anything here already. So I have one question. Can I define dependency between features? Meaning if one is selected, the other must be selected also?
Okay, yes, so this is an advanced question actually. So, okay, so if one feature is dependent on another feature, we have a mechanism that is possible with using it, which is possible to realize it, and so basically you can combine a different set of features based on certain conditions, meaning that if one feature is dependent, for example, on another, so if you have an automated advanced driver assistance system, and then so if you want the autopilot, then it must depend on any advanced driver assistance system. So by using different configurations or interdependencies between those features, you can define using predefined logic that can be as complex as you defined, meaning that if some feature is present or if some set of features present, other features must be present or not present too. And when you define your end configuration, you would not be able to choose, for example, just very blatantly stating, a high-end audio system if the other, let's say, advanced multimedia package is not selected. So we have this. So the interdependency of features is defined based on the logic that exists between them. So
that was very extensive. Another question. Another question. Can you transfer the feature model from CATIA Magic to the platform?
Okay, so not yet, but we have this feature identified, and what I've shown you from in the brief demo, is that we can bring the variability information from the platform to the CATIA Magic. But if we start defining our feature model and the configuration models in the scope of the platform, then it is currently not possible to transfer it to Enovia, and we are working on this. We are aware of this request, actually, but so my suggestion would be, so currently, if you're operating on a broader scope than the CATIA Magic, is that you start and finish the definition of the feature set and the configurations in the platform, and then import it into the CATIA Magic. And also you will be able to reuse the feature set and the configurations on the previously mentioned RFLP objects that are in the entire system of the platform, accessible by many apps and many roles in the platform itself.
Thank you. We have another question here from LinkedIn. What is meant by feature modeling? Can you answer this question?
Sure. So I briefly touched upon what is meant by feature modeling. So the feature modeling is a set of the collective possibilities that is available to you. So for example, let's say that if you are looking for a new car, you pick the brand that you like, you pick the model that you like. But for example, then you are able to pick everything about a car that can potentially be variable. So for example, do you want a 4-door version or a 2-door version? Do you want a gasoline engine or an electric engine? Do you want an audio system, or do you not want an audio system? So everything that you can pick is feature modeling in the basic sense. And part of the feature modeling is configuration definitions. So when you're picking exactly what you want about your car, you're defining your own possible configuration. And we have looked at some before here in the system model. So here, for example, you could say my personal configuration, the end result that you want, and you would have picked a set of features from the number of possible outcomes. But purely from how the feature modeling is realized in CATIA Magic is a set of what is available for choosing and what are the values available for choosing. So either something is there or not, or you can have an electric engine, for example, or a gasoline engine. So this is the core of the feature modeling and the configuration or end product definition based on the features that you choose.
Very good. Thanks a lot for this answer. We are pretty much at the end of our time, but I would like to answer a few questions that were sent to us as well. So this CATIA System Talk will be available in our community, which you can see here, go3ds.com cyber.systems. And here you will not only find the CATIA System Talks from today and the past months, but you will also find a lot of tutorials and self-learning materials. So when you are a starter and you are looking for literature, tutorials, tips and tricks, go to the community, register, it's for free. Thanks. And you can go there at any time and you can ask questions to our experts like Darius, who will answer your questions in his post in the community. So that was really nice. Thanks a lot. And we will see you soon in the next CATIA System Talk in October. Same time, always at 3 and in the community. Goodbye.